The five locations where. Okay. So, hello everybody. The greetings from Heartcare Foundation of India Roundtable. I'm Dr. K.K. Agarwal. Welcome to 39th Roundtable meeting. And obviously, for the last 1 week, I am only reading about the new strain of the virus. Today's topic will be the new strains of the virus. Over to Dr. Kalra.
Thank you. I welcome all the participants to this 39th roundtable meeting of the SCFI. With the recent reports of new strains in UK, South Africa, and Denmark, and few other countries, which has created a lot of sensations and apprehensions in the minds of everybody, including professionals. The main concerns which people are having apprehensions is regarding the new strains, whether it will be more infectious or with the same pattern of original COVID-19, then whether this new strain will produce more severe disease or it will be milder, whether the existing diagnostic test will be able to diagnose this new strain virus, or will again we have to come up with a new diagnostic test or new procedures. Then whether the existing whatever treatment modalities are being utilized, including the monoclonal antibodies, will they be effective in the new strain? And what about the vaccine? The vaccine, which is very now India coming very soon, maybe next few couple of days, whether the efficiency will be and effectiveness will be the same as being tested and will be approved, or we will require some new vaccines. So these are the major apprehensions with the new strains coming up. This is a COVID-19 is a COVID, it is a RNA single stranded virus. All the coronaviruses like flu viruses, they are prone to mutations. But this COVID-19 being behaving differently and also shows mutations, but compared to flu, number of mutations are less. With this background, today we'll be discussing about all the apprehensions which I have expressed. And over to Dr. K.K. Agarwal for
Thank
further.
you, Dr. Kalra. Thank you, Bijon ji, Jai Krishna ji, Upasna ji, Manish Kukreja ji, Dr. Sanchita, Ritu, and many more to join. Now, this virus is teaching us a lot. And every time there is a change, it gives me an opportunity to learn more and go deep into it. My journey started with in 2020. So I had interactions with many people during my various interactions. So I spoke to Dr. Angelique Coetzee. She is the chairperson of South Africa Medical Association. Dr. Pavitra Venkatagopalan, she is the first PhD in coronavirus in India. I had two interactions with her. Dr. Navedita Gupta, the COVID in charge of ICMR. Dr. Jayanti Shastri, the first one to report the genomics of the reinfection in India from Mumbai. Dr. Anita Chakrabarti, our own roundtable member. Dr. J.M. Kaul, who taught us twice on the thymus gland. Dr. Ved Prakash Mishra, who taught me the physiology of thymus, and many others. So whatever I am presenting is based on what they have interacted with me, my understanding, and some of the slides I have taken it from them. So without going into acknowledging slide wise, I'm acknowledging these persons on the very first slide. So you have to see this, that the top 15 countries you are seeing, except in India, Argentina, and Poland, all other countries have shown a second peak. Except in Brazil and Colombia, everywhere the second peak is larger, broader, and earlier than the first peak. Whenever we have a second peak, it comes in our mind two things. Is it behavioral? Is it a human behavior change or a viral behavior change, or is it mixed? It doesn't make sense as a common sense that a wave is persisting and people's human behavior is not changing. If the wave is persistent, second wave is persistent, the human behavior will change overnight because people have learned. So why should a second wave be broader? If the second wave is broader, if there is a sudden spurt, I can understand. But if the second spread is broader, duration is more, we need to look for a viral mutation. If you see in all over, the second wave has started in September. And now December is ending. That means in September, mutations started occurring. Viral behavior started changing. And now the new UK mutation says, yes, it can be traced back to September. Then why suddenly people have talking about it now? Is it because of the vaccine is coming? When the vaccine is coming, there are two concerns. One concern is that mutations may change the antigenicity of the virus. If that's so, billions of dollars spent will be lost and they will have to make the vaccine, new vaccine strain again. So is it the vaccine industry who has precipitated it so that their existing vaccines are utilized in the very first month or 2 months? Or is it a concern, whatever it is? But yes, the new mutation started in September. And now in December, we are talking about it. So closing the borders internationally, is it a knee-jerk reaction? Is a matter of debate. The word variant, strain, and lineage are synonymous with each other in scientific language. But when we talk to the public, we use the word mutant. Whenever there is a mutation, we use the two words, VUI and VOC. VUI means variant under investigation. Once the investigation is over, it becomes VOC, variant of concern. UK mutation now shifted from VUI to VOC. In coronaviruses, the mutations are slow to occur, uncommon. So what is that uncommon has made is common in the last couple of months will be a matter we will be debating. Will be the kindly people are calling that they are not been able to enter in. Saurabh, kindly make enter all the people. So what happened that a virus which was mutating Suddenly for September, we are seeing large number of mutations. Let's say a simple example. There is a name called Amita. Amita will remain same as Amita if you make 2I, if you delete I, if you make 2A, if you make 3A, if you shift I to E, A smaller. That means these are called antigenic drift without changing the character of Amita. But if you make I replaced by U, then you don't know whether it is same Amita or not. Now remember, just see the RNA because we are not discussing the DNA. There are only 4 nucleotides, and these are cytosine, guanine, adenine, and uracil, which makes all the amino acids in the world. Only 4 of them: cytosine, guanine, adenine, and uracil. In a permutation combination, 3 of them unite to make a amino acid. 3 of them will be the instructions together. It is like the whole computer language is written with 0 and 1. Similarly here, cytosine, guanine, adenine, and uracil makes the whole universe. Again, don't see the DNA level because just now see the mRNA level. If it is AAG, it is lysine. If the mutation for G replaces by A, it becomes AAA. It is called silent mutation, but the body will still recognize it as lysine. If the mutation becomes UAG, A is replaced by U, then whenever there is a UAG, it is called as a stop codon. Codon is a 3 nucleotide together, becomes a codon. And whenever there is a UAG, this is a mutation to tell, whenever UAG comes means stop printing. Then AAG becomes AGG, it becomes arginine. And if AAG becomes ACG, it becomes threonine. So now you can see how different types of mutations can make different types of proteins, amino acids. Here you can say here that when the messenger RNA 3 together makes a particular type of amino acid, these are the shapes of amino acids, which tells us that a variable side chain decides which amino acid will form. Now, there may be multiple mutations. On the left side, there are so many mutations which are occurring, and then out of which there is a survival of the fittest. Whichever mutation feels that it can help him in any of the function, those mutations will survive and other mutations will not survive. Now, why should we have genomics? Why should we, all of us, learn genomics at a school level, at a UG level, PG level? Because if genomic was there, we would not have discovered the new virus. We would not have developed the diagnostics. We would not have gone to formation of a vaccine. We would not have been able to track transmissions in various countries. We could not have identified reinfections, and we could not have understood the host virus reactions. Now, there are 5 things this virus can do, mutation. It can change the ability to spread more quickly, early, broader, larger than different populations. Tomorrow, you may say that the new mutation is causing more loss of smell and more loss of taste, which is likely in the new virus. Tomorrow, you may say it is spreading more in children, more in antenatal. Tomorrow, you may say this is now, even by whispering the virus is spreading. Ability to cause the disease. Tomorrow, you may say the mutant virus is causing more cytokine storm, more antigenicity, More inflammation, more clots. Ability to evade detection by a specific diagnostic test. The mutation may make a diagnostic test invalid. Decrease susceptibility to therapeutic agents such as monoclonal antibodies. They may not work. Ability to evade vaccine-induced immunity. The new strain may not allow antibodies to form, may not allow the cellular immunity to work, may not allow the humoral antibodies to work. This is how two viruses, SARS and MERS, look like, and you will see they have similar. So when there is a SARS becoming a MERS, that means a antigenic shift. You see, ORFA is the same, ORF1b is the same, S is the same, and then 3A, 3B, these are slight changes. E is the same, M is the same, N is the same. So there are some changes in the non-structural proteins. So multiple gene mutations made SARS into MERS. Similarly, you see in the spike protein, in the MERS, there are 1353 genes, and here there are 1255. That means 98 genes got deleted. That means there were lots of changes in this MERS to form SARS. Now we come back to SARS only. Now in the SARS only, you will see the mutation can occur in ORF1A, in ORF1B, in S, in 3A, 3B, in E, M, 6, 7A, 7A, 8A, 8B, 9B, or N. All these locations, mutations can come. So whenever you have a mutation, first you ask yourself, where is the mutation? And then you say, is it in the S? You say, yes. Then you say, then you get concerned. S protein mutation you don't want. If it is in the S, you start looking for, is it in the S1 or S2? In S2, you still say, okay. But if there is a mutation in S1, you say, I am worried because now it's a variation of concern. In S1, then you say, is it in RBD or non-RBD? You say non-RBD, you say, okay. But if you say in RBD, this becomes a variant of further concern. In RBD, you say, is it in RBM? Now, what are these two? RBD is the receptor binding domain. This is the area which attaches to the ACE2 receptors. RBM is that portion of RBD which gets fixed to the ACE2 receptor. So RBM variation is the most important. RBD are very important, others are less important. All are important. Now we will see here that in South Africa strain, there are 3 mutations, one in this green, then in red, and then in green. So there are 3 mutations in RBD with one of them in RBM. The mutation in UK are multiple, but there is no mutation in RBM. So theoretically, South African strain should be more contagious than UK strain. Remember, there are genes 1 to 1255. So we will be using these slides to understand various types of mutations. Now here we will try to understand the role of each part. So ORF1b, these are called non-structural proteins. They are responsible for virus replication. They are responsible for proofreading. They are responsible for suppressing cellular immunity. And out of this, NSP14 we are going to focus further. So different types of proteins are responsible for various types of viral replication. None of them we know which is responsible for causing inflammation or thrombosis. How do we classify these? Every day we learn that China, the disease started with the L clade. Clade is same as a mutation. So the Wuhan was L, then it became S, then it becomes V, then it becomes GH, then GH, then GR and GV. Every day you listen, you say which gene it is, you say this is a GH strain, you say this is a GR strain, you say this is a GV strain. What do they mean? They mean that in the amino acid sequence, there is a shift. So there is a S amino acid has come now in 84. Then there is a G means glycine in 614 gene. G for glycine has come. So they tell you one or two genes, amino acids, replaced in which gene, and in the bottom they will tell you what differences they are making. So GH will affect the ORF3A. So this is how GH ORF3A. So this mutation will come here. GH mutation will come here. Then if you see India, there are so many mutations already. We have GR, GH, all types of mutations are seen in India. That means every state may have a different mutation. Every city may have a different virus. Because in India, we have seen GR, GH, G, S, L, V, and O is unclassified, which is important. As on today, all the new viruses are unclassified. That means in India, we have detected more than 460 such types of genes which are unclassified. These multiple unclassified can mix together to become a significant change. So mutations are occurring all the time. Now we come back to any RNA viral is likely to make more and more mutations, which we will come back why. Now here comes the difference between an influenza versus COVID-19 virus. Whenever a virus enters, hijacks my photocopying machine, before it starts making the first copy, it will make a sample proof for proofreading. Those of you who understand the printing industry understand that the first proof copy comes for checking. And that proof checking basically is the job of NRP, that is NSP 14. So NSP 14 protein checks the proofreading. If the proofreading mechanism is not there, there will be more mutations. And if you have seen a classical Three Idiot movie, Chamatkar becoming Balatkar, because the proofreading mechanism was not there, and it changed the whole meaning of the movie, Chamatkar to Balatkar. And here, if you see here, in influenza, that mechanism is not there. So therefore, influenza changes its immunogenicity much more often than COVID-19. So the proofreading mechanism is present. Therefore, antigenic shift becomes unlikely. Now, these are the different types of COVID, the genomic architecture of SARS-CoV-2. These are the different key mutations with their associated effect. So these are the different types of mutations which are seen all over the world. So even in India, in some mutation, you will have different types of genes. And what do they cause? So here, this is a matter of record that every mutation will be associated with something. Deletion of 6970, N439K, N501A. Why? That means these genes mutations are well known to occur in every country, isolated together, unless they make a party together. When they make a party together, it becomes important. Now, the first gene which is prevalent today is D614G. This is the most prevalent strain today. That means where is 614 after RBD in S1 in the blue structure. That means here the amino acid was aspartic acid, which has been replaced by glycemic acid. It is like a cricket where one player is changed. You say new cricket team, we will replace today this player with this player. That becomes D614G. Because of this mutation, two things occurred. One in favor of the virus, one in the favor of the human beings. D614G increased coronavirus replication and infectivity, but also make the virus more vulnerable to neutralization by antibodies. Therefore, D614G increased infectivity but reduced virulence. Therefore, after the introduction of D614G, mortality all over the world reduced. We started seeing less of cytokine storm. Now we come back to the Nigeria strain. In Nigeria, they are saying we have a P61681H mutation, which is an isolated mutation, which is that at 681, that means where is 681? After 679, it is in S2 protein. So it is in S2 protein. So we say, therefore, this has not been become significant. Nobody is talking about it, but they are now talking about it, 681 proline to histidine substitution. But there are scattered reports are coming, but nobody is taking it significantly because it is in the S2 subunit. Now, this is one slide which says, in the RBD areas, which are the sites which are more important? 455, 486, 493, 494, 501, and 505. So these are the most vulnerable genes, out of which, because 501 has been involved, therefore people are talking about it. So these are the areas in RBD, locations which are of importance. Now we went back to the UK. UK variation is VUI to VOC, virus under investigation to virus of concern. It is 2020, 12 is December, 1 is the first mutation. It contains 23 gene mutations. More is 501. Let's see where is 501. Oh, after RBM in the green, it is in the RBD, matter of concern. Is it a matter of concern gene? Yes, ASN 501. So I'm worried about it. So there is it caused a worry. Then this causes two deletions, 69 and 70. That means position of amino acid 69, 70, and 144 got deleted. Apart from that, there were other mutations, but none of the mutation is in RBM and only one mutation in RBD with two deletions and multiple other. Now here it tells us that, on the right side, wherever there is a red line, that is the mutation. Now you can see the central one arrow is the one which is the most important, but we also have multiple mutations occurring in various parts of the body, including non-spike. So lots of mutations are seen in non-spike portion also. If you see this spike protein mutations, the deletion 69 and 70 is changing the shape of the spike protein. Therefore, this 6970 may make the S gene test unreliable. As on today, this is a speculation because of 6970 deletion in a RT-PCR test. The S gene may make the test unreliable. N501 makes the receptor binding more potent. But there is another important, the Y145 deletion is the area where neutralizing antibodies stick. So still we don't know whether Y145 deletion will make my neutralizing antibodies less effective. We don't know. Now, these are the various mutations in the UK virus. One of them is 681H. This is the same mutation which is seen in Nigeria, Nairobi. So in the Nairobi mutation, the 681 mutation is common. So maybe that Nairobi mutation was one, and that also has gone into the UK mutation. I'm not going into further details of that. So if you see in UK, the new virus is stronger, broader, quicker, earlier. Therefore, the new virus started in September, picked up in December. So there has been a surveillance failure of 3 months in picking it up. And now suddenly there is a knee-jerk reaction on this virus. Reasons can be two. One, reason is only one, and that's a vaccine introduction. So the further reasons can be two, plus or minus. Minus is all the companies wants their vaccine to finish up early because they say that they may have to make a new vaccine with a different strain, or their concern is the vaccine may fail. That's their concern. Therefore, there is a reaction. Otherwise, this virus is present in UK since September, even by the UK officials. Even the yesterday South Africa Health Association, Health Ministry press release has said that UK virus came earlier than the South Africa virus. Now we come back to the mutation in South Africa. Now here I am worried. This is 501. 501 means in this green part. This says 417. That means in this green part. And they say 484 in the RBM. So there are three variations. I'm not going into the detail of what amino acid replaces what amino acid. Important is there are three mutations in South Africa, and all the three are in spike, S1, RBD, with two in RBD and one in RBM. Therefore, it makes more significant virus change than the UK addition. And it further makes sense that South Africa virus came after the UK virus because there is an addition. There is no substitution there. And if you see here, in the first wave of South Africa, there is no yellow strain of the virus. And suddenly you see here, all the strains have become yellow. That means the last line you can see 100% new strain. That means practically in South Africa, this virus has replaced earlier viruses. This is how, when you talk about the virus spike protein, it has three petals. Every petal has a RBM and every petal has a RBD. And RBD is also the target for neutralizing antibodies and vaccines. So whenever there is a variation or a mutation in RBD, therefore you are bothered about neutralization of antibodies. This is how the three mutations would look like. These are the three mutations, spike RBD domain, and these are the three mutations, one in the RBM and two in the non-RBM. So the central one is the RBM. So this is the area where three mutations have taken place. The 501 enhancing binding affinity to ACE2, 484 enhancing binding affinity to and confer resistance to class 2 and antibodies. So neutralizing antibodies can be class 1, class 2, class 3, and class 4. So 484 class 2, 501, then 417 class 1 antibodies, it may have. So therefore, when antibodies, class 1, class 2, antibodies are getting involved in the mutation, that means such types of mutations may not allow the antibodies to kill the virus so effectively. Now here you can see the graph in South Africa. You can see the second graph is, in the first graph, it took from March to May, so many months to rise. And suddenly you can see the graph is much earlier. So this case is March is much earlier. It tells you the second wave is much stronger. And it again tells you the second wave is much earlier in different areas of South Africa. Now, this is the graph on the right side, which tells you the abbreviations. A for alanine, R for arginine, N for asparagine, D for aspartate. So therefore, this is how the viruses are classified. Now we come back to another mutation which has occurred in Denmark. This is important to understand. In Denmark, there was a mutation on 4th November. They found out a mutation in the minks and in the human beings. They killed all the minks. Lockdown and travel restrictions were introduced. And on November 19th, they said this strain of virus has become extinct. But if you see in this virus also had 6970 deletion, which is now there in the UK. So therefore, a mutation came in Denmark in September. Probably that mutant did not survive for a survival of fittest, but 6970 out of it was adopted by the UK virus. Now, this is the most important thing which I want to discuss. When the virus enters my body, it uncodes into genomic RNA positive. Then there occurs a translation by non-structural protein ORF1A and ORF1B, which makes the proteins through RNA-dependent RNA polymerase, whose job is to do complete printing. One of the job assigned of RNA-dependent RNA polymerase is to NSP14. NSP14 is the proofreader. His job is to call Chamatkar as Chamatkar. Now, if you destroy this NSP14, then mutations will increase. That means in the last 2 months or 3 months or 4 months, something has happened which is destroying NSP14 in a virus, and hence mutations are occurring. And we know today that in an immunocompetent person, doesn't matter even if you destroy the NSP14, but in an immunocompromised person, if the virus remains alive for more than 100 days, and if the proofreading mechanism is disturbed, then the viral replication will increase. Viral mutation will increase. And that's what people are presuming, that in an immunocompromised people, continuing existence and replication of the virus with killing of NSP14 may be, I said may be, responsible for increasing number of mutations being seen after September, many of them becoming variants of concern. Now, what kills NSP14 are remdesivir, favipiravir. Therefore, drugs like remdesivir and favipiravir, which has to be given early in the course of the disease, that means on day 1 and day 2, when the viral load is high. If you give them at a time when the viral load is very low, that means after 2 weeks, after 3 weeks, giving remdesivir, favipiravir continuously for longer period of time, it's something like AMR, antimicrobial resistance. It suppresses NSP and mutations may come. This is an hypothesis based on the virological phenomena, because remdesivir is known to suppress NSP14. This has come from Dr. Pavitra, who is the first PhD on in virus. Therefore, we need to be concerned about it. All over the world, people are also talking about the role of inadvertent use of convalescent plasma. They say a 65-year-old cancer patient who survived after 105 days with the virus, and one of the mutation recently spotted in South African variant, which is N439K, which may allow the virus to bypass monoclonal antibody drugs, happened in that particular patient because he used 3 treatments of convalescent plasma starting on day 63. So convalescent plasma has large difference in potency between doses due to natural variation between the array of antibodies produced by the immune system of the donors. In a recent preprint, scientists document mutation of the virus after a patient received 3 treatments of convalescent plasma starting at day 65 of their illness. 2 of the viral mutations developed in spike protein. This is now this is similar, something similar happened inside a 65-year-old cancer patient with N439K mutation. So these are the 2 theories which are coming, that why suddenly variant of concerns have come only in the past 3 months. 614 was the only variant of concern initially, and suddenly we are getting cases that South Africa is different, Netherlands is different, Nairobi is different, and now we have seen new UK strain in Japan. Multiple cases have been identified in Singapore. So all over the world. So I'm going to end with the first slide again. And according to me, since September, in whichever country we are seeing a higher peak, a earlier peak, and a stronger peak, I will not be surprised if all of them comes out to be a new variant of the virus. Thank you very much for giving me this opportunity to talk. Anita ji, because
I thought you made it so simple. I must tell you, my friend has also been watching, who's a doctor, and we really appreciated it. I mean, you made it clearer than a virologist, because virologists make it more complicated, I feel so.
That's right. That's right.
In the first slide, I acknowledge.
Very well said. Very well said. Very well said.
First slide, I acknowledge you also that I have learned it from the following people, including Anita ji.
Thank you so much.
My job is, I am only working as a communicator, because Sunila ji says whenever you want to communicate anything, it should belong to the experts through the mouth of a person who can communicate. So I have picked up the material from various experts and communicated. That's all.
Excellent, excellent.
So, Dr. Agarwal, my question is that that means when we did the solidarity trial also, or we did the trial with the convalescent plasma at that time, we knew that
the variant may have been different.
Yeah, but then only thing is that from this juncture we need to bring out, we have got 6 surveillance sites in India. Why you see the mutation data is not there in the public domain? Because you see, Britain keeps doing this regularly, and so is Africa also is doing. So why we have to learn from them? We also have our surveillance sites, and why we don't bring the data in public domain, or we are not doing that? Is another point.
I'll tell you, Sunila, that I have taken one job, and that job is up till now, the job of a doctor was, this is a virus, this is a drug. This is how we have been taught. We were taught that in the college, we were taught full class, and at the end we were used to taught, forget everything, remember only this. that there is a malaria, there is a chloroquine. Rest everything was, they said that only thing to remember is chloroquine and malaria. So we used to forget what was taught to us. So I want to revive in India, and the full 1 year I'm going to devote on basics, physiology, anatomy, microbiology, biochemistry, I am going to inculcate it at a GP level, that people start thinking the need for it. At this moment, people will say, even if it is there, it goes above us. But I am now, this lecture, I'll give it so many times that people will stop saying कि ऊपर से चला गया, कुछ तो जाएगा अंदर.
नहीं, बिल्कुल जाएगा, Dr. Agarwal. It is very important, and what you have explained, and as a common man, you know, I always come here to learn as a common man from the scientists, from the experts of our country. And what did I learn today? That, as you said, you know, you gave a good example. You said, ये है तो इसके लिए ये दवा ये है तो उसको दे दो. But today you explained that there is something called a human being in between, and that person can keep having various variants, and so it is not an end all, you know. So you see, the biggest debate which happens always in the public domain is ये कैसे हो गया? That means डॉक्टर ने गलती कर दिया. No, डॉक्टर ने गलती नहीं किया, तुम्हारे बॉडी ने कुछ में ऐसा हुआ कि जिसमें रिएक्ट हुए. So these kind of communications which you gave is extremely important, and I am very happy that, you know, professors like Anita ji and Sunila ji and all, they have all acknowledged the way you have explained, you know. So these are good examples of how to communicate with the common man, you know. So I think such things could be made more viral, more known, more you know, educative to the citizens, so that there is no differences in terms of, you know, understanding. And that is what I want to say today, you know, in this.
Can I add something?
Yes, madam.
Sunila, actually,
Please,
the data is available regarding sequencing. The first data started from IGMR itself. They have done some ICMR along with NIV, has done some very good work. And I must tell you that an NIV doctor is a virologist from CMC Vellore, Priya Abraham. For a change, we don't have an entomologist, but we have a virologist. So that makes a lot of difference. Very dedicated lady. So we have the data, and but they are frankly in you know, like microbiology journals and virology journals, which do not get so much access. People will not read it maybe in your field,
No,
you know.
Anita, no. Our
Easily.
question is that it has to be, you know, it has to have an implication. You see, now
Yes.
we are looking at the implication part, that we have got so many number of cases which are highly transmissible, may not be very severe. So that is what makes us, you know, Britain became more conscious, because suddenly there were so many hospitalizations, you know, the beds were full. So there was a public health perspective to it. So everything has to be translated. That day I was listening to Dr. Ramesh, a virologist who is now director JIPMER, and he was explaining to us, you know, like 4 children are given 4 kinds of beads, and you tell him to make the same string. So every time Dr. KK Agarwal was also telling that, you know, it will not be the same, you know, it will be different kind of string. So somewhere, you know, we have to make everybody understand that this is how the mutation is, because we all come from different backgrounds.
I'll just add, I'm sharing one slide called nexttrain.org, which is an international given to me by Pavitra yesterday. This is NextTrain SRS COV2 resources. This talks about every time in every country it tells us which genomics are there.
Yeah.
So suppose I go to India, and India, there is a Vinod Skaria lab which is talking it. Nobody else is sharing. The government is not sharing data with them. And then it tells you the genomic informatics. Then it tells you the genomic informatics. And if I back to the global, so in the global, you can latest global analysis.
Sir, Dr. Manisha here. The 2 points that are stuck in my brain are one is the use of convalescent plasma and remdesivir favipiravir. So giving these should
when not
be
indicated. When not indicated.
When not indicated, yes, they are being given. So the misuse.
This is what, just hold on. This is what the whole graphs will look like, different types of mutations.
Yes.
I mean, I'm now studying more into it, that how this looks like mutation. So this is how you tell, these are the which mutation is occurring in which country, What does it mean? So it will take me another 1 week to understand.
So this is phylogenetic analysis. They will show you that if there is a similarity between the lines in different geographical areas. So phylogenetics explains the genomic spread in different geographical region, and this is through the computer. And they usually there's a blast. There is software. The softwares play very important roles. So the gene sequences are blasted on the software, and then they show you the analysis. Like, see, you can see the reds. So the reds would be from even different areas. So you come to know how it is spread. So Sunila, epidemiologically also this becomes very important. But then this isn't easy to interpret until you're into it, That's the main thing. I agree with
Let's say
Sunila and
A for Asia. If I pick up A for Asia, it says in Beijing, nucleotide mutation was C6026. Now AA mutation, divergence, date, region. So every mutation we can find out here. So in Beijing in June 2020, on 602 amino acid, 6026C replaced by T. That's how you can trace. That's how you can trace.
Mainly, we must try and put across these, the mutations are happening because of the misuse of plasma as well as antivirals.
I said this is a speculation. I am not, because tomorrow I will become hated by the companies who are making Favipiravir and Remdesivir.
Actually, we are working on empirical treatments.
So
From
at the moment, I am only discussing possibilities of a misuse, not use. So the word use is fine. Misuse, I'm using the word misuse. So Anita ji, I have a request. Keep guiding me, because I am giving these presentations again and again with modifications. If you feel any further I need to modify, kindly guide me. Because I'm representing all of you when I speak. I'm writing that I've learned from Dr. Kaul, Dr. Anita, Dr. Pavitra, Dr. Navedita, Dr. Shastri, Dr. Jayanti. So all of them who have taken sessions with me, every time I learn a new thing from them.
Very good. Very good. Yeah, very nice. This was very good. In fact, I liked your phrase Chamatkar to Balatkar.
Yes, that's what invitation is.
So I like that phrase of yours. And also today I learned variant of concern, from variant of investigation. So
under investigation.
You will become a virologist, Bijanji, soon.
No. I want to be a patient advocate. I would learn from the virologist every day, every time. I like to learn. And it's very good, it's very good.
If there are no other questions, I'll request Anita ji.
Thank you.
Yes,
just a comment, KK. Wonderful explanation. Even a surgeon like me could understand everything. Thanks for making it so simple. Wonderful thing. Thank you. Thank you, KK.
Thank you, Ashok. I'll request Anita ji to give a final comment, and then Dr. Kalra and Dr. Jayakishan, you want to say something?
Nothing, sir. Nothing, sir. It was a very informative talk, sir. Thank you.
Thank you.
Anita ji, I think so. Is it so? Yeah. Thank you, Dr. Agarwal, for such a lucid presentation of such a complicated subject. And this is the need of the hour. And we have thoroughly enjoyed it. And especially one relevant point, most relevant was the RBM, which you told. And the second thing was the vaccine escape mutants. But hopefully this will not occur like it occurs in hepatitis B. So we just keep our fingers crossed so that we just need to tweak the vaccine if there is some problem. And so please continue with your wonderful lectures, and your PhD student is really good. Tell her, give her the appreciations to her. And pass on the slide to me. Let me go through it in detail, please, if you don't mind.
Yes, madam.
Thank you so much. Thank you. It was a pleasure.
Thank you, everybody. Dr. Kalra.
Thank you, sir.
Dr. Kalra, you to unmute.
Thank you, Dr. K.K. Agarwal. As usual, You have made such a complex topic very simple so that everybody is understanding. And mutations are a natural phenomena in viruses. And one should not unnecessarily, the key message is mutations are known, they will be occurring. We should study them, we should know them, so that accordingly treatments, and if required, vaccination, some improvement is required, can be done immediately if you are aware about all these mutations. The only key message is nothing to worry, but precautions to continue, as natural death of this virus is not going to be take place in near future. So we must continue all the usual precautions we have learned the last 10 months. We must continue. And thank you. I thanks all the participants for attending this session, and see you again next week, same time, with a new some interesting topic.
Thank you. Thank you, Dr. Kal.